tape recorders used as spaceborne mass storage devices had a history of being heavy and unreliable and requiring extensive, costly ground testing for launch readiness. Utilizing bubble memory modules as a building block to pave the way for replacing tape systems with solid-state recorders created a technological shift in the aerospace industry.
Buck Rogers, Flash Gordon, they were big when I was a kid, and yes, I always wanted space.
SEAKR was founded by Ray Anderson and his oldest son Scott in 1981. Their initial SBIR contract was to replace tape storage for military weather satellites. The Colorado family-based company SEAKR is an acronym for the father and his three sons, Scott, Eric, Kurt, and Ray Anderson.
Scott and my father Ray had the opportunity to start a business, and then the SBIR program came out, and they started looking through a large catalog of opportunities of replacing tape recorders in satellites. Prior to switching to a solid-state recorder, all Earth-observing and planetary satellites had tape recorders that stored their data, and they were very difficult to build. You can imagine in a zero-G environment having a tape system that with moving parts would be problematic.
The accepted knowledge was that dynamic rams wouldn't work in space because of the radiation environment would flip bits.
It would upset, flip bits from ones to zero. Well, the answer is to put an error detection and correction code on it and correct it mathematically, allowing a very inexpensive commercial device to be used in space.
We were able to come up with a dynamic RAM recorder. So the whole world now uses dynamic rams.
With the help of several small business innovation research contracts, SEAKR became the driving force behind the premier producer of solid-state recorders on the market.
It really became the foundation of the company's growth. It gave us a focused ability to develop our reputation in the aerospace electronic marketplace. Almost all of our product line really now helps the Department of Defense and all the things that they do to keep us safe, mostly through data processing and imaging. It's about getting smaller, getting lighter. Size and weight matters a lot in space. People weren't really going to want standalone recorders anymore, but data processors and spacecraft control systems that are combined, and they've just invested heavily in our internal research and development to keep that product line going and make it better and better and smaller and more capable.
With the success of solid-state recorders, or SSRs, under its belt, the company honed in on its next target, onboard processing systems for space and aircraft. Again, SEAKR received an SBIR contract to fund the development of its new line of real-time processors that could send data directly to facilities on the ground.
So we won a second SBIR. We've actually won several, but another SBIR took forward the concept of doing onboard processing on a satellite. Rather than collecting all the data in a solid-state recorder and sending it to the ground, actually bring information to the ground and do processing on board the satellite. So we took many of the things we did in a solid-state recorder, power supplies, control boards, I/O, and applied that to becoming a processing company. Without the SBIR program, there wouldn't have been a SEAKR.
Built up to over 450 or so employees now, and I think the future has great things in store for us.
Our product has changed the industry, and the missions that we go on expand human knowledge. We've mapped out the moon, we've orbited Mars, we just arrived at Juno. We had thousands of deliverables, hundreds of which are in space, and every single one of those can be traced back to that original SBIR contract. In that way, you could really make the argument that SBIR created this company.
To find out more about the Department of Defense's SBIR program, go to www.sbir.defensebusiness.org.